Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to derive mean value of a Gaussian random variable. First of all, the probability density function of a Gaussian random variable is fx of x is equal to 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square. So in this equation, capital X is the Gaussian random variable and this small x is the value of the Gaussian random variable. Small m is the mean value of the Gaussian random variable and sigma square is the variance of a Gaussian random variable. So this expression, this concept, Gaussian distribution concept already explained in my previous videos. Please refer that videos. Now here we want to calculate mean value of the Gaussian random variable. So we know that the mean value of the Gaussian random variable is given by expectation of x is equal integral minus infinity to infinity x into fx of x dx. So this expectation of x is also called as first moment of the random variable. So expectation of x is also denoted as m suffix 1 or simply m. So now here capital X is the uniform random variable. This is the expression of the probability density function of the uniform random variable and substitute this fx of x value into this equation. We get expectation of x is equal integral minus infinity to infinity x into 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square dx. So the RHS term, this exponential term is written as e power minus of x minus m by sigma whole square by 2. So now here on RHS side, let x minus m by sigma is considered as a t. X minus m by sigma is equal to t. Take the cross multiplication. X is equal to, this m is going to the RHS side. We have x is equal sigma t plus m. So differentiating with respect to t, dx is equal sigma into dt. So now here in this equation, x ranges are minus infinity to plus infinity. Now here we are considering x minus m by sigma is equal to t. Next calculate the ranges of the t. So in this equation, substitute x is equal to minus infinity and x is equal to plus infinity. Then we get ranges of the small t. Substitute x is equal to minus infinity and x is equal to plus infinity. The ranges of the t also minus infinity to plus infinity. Applying all these considerations into RHS term of this equation, we get mean value of the random variable is integral minus infinity to infinity x. So x is equal to sigma t plus m into 1 by square root of 2 pi sigma square root of sigma square under root is cancelled, sigma 1 by square root of 2 pi into sigma e power x minus m by sigma is considered as a t. So e power minus t square by 2 into dx. Dx is sigma dt. So now here numerator and denominator sigma is the cancel. 1 by square root of 2 pi is written before integration. 1 by square root of 2 pi integral minus infinity to infinity sigma t plus m into e power minus t square by 2 dt. So multiplying this e power minus t square by 2 within the bracket term, we have expectation of x is equal sigma by root square root of 2 pi integral minus infinity to infinity t into e power minus t square by 2 dt plus m by square root of 2 pi integral minus infinity to infinity e power minus t square by 2 dt. So from this equation, multiplying this e power minus t square by 2 within the bracket term and applying the integration into both the term, we get this is the equation. So now here in the RHS side of this equation, the first integral term is sigma square root of 2 pi integral minus infinity to infinity t into e power minus t square by 2 dt. That is the first integral term. Now here this is considered as the function g of t. So since g of t is equal t into e power minus t square by 2. So now here this is the function g of t. Now here in this function small t is replaced by minus t. We get g of minus t. So g of minus t is in this equation t is substituted by minus t. G of minus t is equal minus t into e power minus of minus t square by 2. So minus t square is t square. So minus t into e power minus t square by 2. So t into e power minus t square by 2 is function g of t. G of minus t is equal to minus g of t. Okay, I will explain here. And this is the function g of t. So now here t is replaced by minus t into e power minus of minus t whole square by 2. So minus t whole square is minus t into e power minus t square by 2. What is this one? This is the function g of t. So therefore minus g of t. Substitute t is equal to minus t. G of minus t is equal to minus g of t. So the function g of t is an odd function. The function g of t is an odd function. So the function g of t is an odd function. So integral minus infinity to infinity g of t dt is equal to 0. Integral minus infinity to infinity g of t dt is equal. G of t is t into e power minus t square by 2 dt, which is equal to 0. So now second integral term, integral 1 by square root of 2 pi integral minus infinity to infinity e power minus t square by 2 dt is the area enclosed by the Gaussian random variable, that is n of 0 comma 1, and its value is equal to 1. So therefore from this equation expectation of x is equal, the first integral term is 0 and the second integral term is the area enclosed by the Gaussian random variable, which is equal to unity. Therefore expectation of x is equal to 0 into 0 plus m into 1. So therefore the mean value of the Gaussian random variable is mean value of the Gaussian random variable is m. This is the derivation of mean value of Gaussian random variable.